Hello and welcome back to another video. In this problem, we're asked to find f plus g, f minus g, f times g, and f divided by g, and state their domains. So we have f of x is equal to the square root of 3 minus x, and g of x is equal to the square root of x squared minus 1. So the first thing we have is f plus g. F of x plus g of x is just these two square roots added together. And there's no like terms that can be added here, so we just have to leave it at that. Same thing with f of x minus g of x. This is equal to the square root of 3 minus x minus the square root of x squared minus 1. F of x times g of x. This is simply equal to the square root of 3 minus x times the square root of x squared minus 1. And what we can do is we can multiply these two things within a singular 3 minus x times x squared minus 1. And we are going to simplify this to be 3 times x squared minus 3 times 1 minus x times x cubed. Sorry, x times x squared is x cubed minus 1 times x. And finally, we have f of x divided by g of x, which is the square root of 3 minus x divided by the square root of x squared minus 1. So we have a couple things here. We have the fact that the square root of all of these, whatever these square roots are, have to be greater than or equal to 0. Right? You can't take the square root of a negative number. So for a and b, the domain, and I'll write a, b, c, d, right? This is the actual functions themselves. For the domain, for a and b, 3 minus x has to be greater than or equal to 0. Therefore, x has to be less than or equal to 3. And x squared minus 1 has to be greater than or equal to 0. Therefore, x squared has to be greater than or equal to 1. And x has to be either greater than or equal to 1 or less than or equal to negative 1. What is the overlap of these things, right? If we write x is less than or equal to 3, x can either be greater than or equal to 1 or less than or equal to negative 1, but it also has to be less than or equal to 3. So x can be less than or equal to 3 and greater than 1, or x can be less than or equal to negative 1. And this is the domain for a and b. For c, it is a little bit more complicated. So we have 3 minus x times x squared minus 1. So what we're going to do is we're going to find what in this is greater than or equal to 0. So for this, we have 3 minus x, right? And I'll do this, I'll make sure this is a separate section. 3 minus x times, this is a difference of two squares, x plus 1 times x minus 1. And this has to be greater than or equal to 0. So what you do is you take the number line and you take all of these zeros. So this is positive 3, negative 1, and positive 1. And you find values in between them and determine whether or not in this interval the function is positive. So let's just try 0. So that would be 3 minus 0 times 0 plus 1 times 0 minus 1. That's 3 times 1 times minus 1, which is negative 3. So that means all of the values in this range are negative. And since we don't have any repeating roots, we alternate between positive and negative. So therefore, for c, x can be less than or equal to negative 1, or 1 can be less than or equal to x can be less than or equal to 3. And you notice that this is the exact same as a and b, right? Because in this final form, the restrictions on the domain come from the original functions. And so we can say that the values that are not allowed in this and in this are also not allowed in this because it is a product of them. So that's C. We can do D up here in the last little bit. So this has to be greater than or equal to 0. So therefore, x has to be less than or equal to 3. And here, this has to be greater than or equal to 0 for the similar rules that we've had the whole time. So x has to be greater than or equal to 1, or x has to be less than or equal to negative 1. And this cannot be equal to 0 because it's in the denominator. So x cannot equal 1, x cannot equal negative 1. So what this means is this is a very similar domain, except these two together create a slightly different restriction. If x is greater, has to be greater than or equal to 1, but it's not equal to 1, then x can be greater than 1. And x is still less than or equal to 3. That doesn't change. And then x can also be less than or equal to negative 1. However, it can't be equal to negative 1, so therefore it's less than, strictly, negative 1. So here we have our 4 functions, a, b, c, and d. The domains for a, b, and c, as we found separately, is that 1 is less than or equal to x is less than or equal to 3, and x is less than or equal to negative 1. And we have a very similar domain for d, right? X has to be greater than 1 and less than or equal to 3, or x has to be less than negative 1. So that is f plus g, f minus g, f times g, and f divided by g for these two functions, f of x and g of x.